What if the oldest part of your house could actually become the smartest? We tend to think of chimneys as, well, just a pipe for smoke, right? But we've been digging through the technical designs for a system that completely transforms this ancient feature into a high-efficiency energy hub. So let's dive in and see how this reimagined chimney really works.
I mean, seriously, think about it for a second. For hundreds of years, a chimney has just been a simple pipe. It vents smoke, sure, but it also vents a massive amount of valuable heat straight out into the sky. It works, no doubt, but is it efficient? Not really. The designers at TechRox asked that exact same question, and believe me, they came up with a pretty radical answer.
And here it is. This is that answer, the G2 Home Trapping System, or HTS. Look, this isn't just a chimney anymore. It's an entire ecosystem. It's built around this incredible idea that smoke isn't waste, it's actually untapped fuel. It's basically a modular thermal processor that's designed to capture, clean, and then redistribute that energy throughout your home.
So how in the world do you turn a simple chimney into an energy generator? Well, it all starts by rethinking the very first thing a chimney does, getting rid of hot air. Let's take a look at how this system actually grabs that energy before it's lost for good.
The concept here is just so elegantly simple. Instead of giving the smoke a straight shot up to the sky, it gets routed through this maze of winding copper tubes. Now, as you know, copper is an amazing heat conductor, so as that hot smoke snakes its way through, the copper just pulls that thermal energy right out of the exhaust.
And check this out. Every single part here is engineered to be as efficient as possible. The copper coils are doing the heavy lifting, obviously, but they're enclosed by heat-reflecting walls to trap every last bit of that energy. It's even backed with drywall for insulation. But this low-power fan, now that is a stroke of genius. It actually slows the smoke down just enough for the coils to extract pretty much all of its heat. So clever.
Okay, so we've trapped the heat. Awesome. But what about the smoke itself? The pollution. That's where the second part of this whole ecosystem, the J2 module, comes into play. Its job is to literally wash the exhaust before it's ever released into the air.
This diagram shows a concept that is, again, surprisingly simple. The best way to think of it is like a car wash, but for smoke. The exhaust enters this chamber, called the smoke condensation chamber, to get scrubbed clean of all the nasty stuff like soot and dust. The science behind this is something called electrostatic precipitation. Basically, the system uses these charged plates that act like powerful magnets for pollutants. As the smoke passes by, these plates literally just pull the particles right out of the airstream. It's pretty cool stuff.
So here's how that whole process plays out step by step. First, a fan pushes the now cooler smoke into that J2 chamber. Then, inside, those static plates act like magnets, just grabbing all the dust. After that, a fine water mist makes those captured particles heavy, and they fall down into a collection tray to be drained away. And what are you left with? Only clean, cooled air getting vented outside.
All right, so we've captured the heat and we've cleaned the smoke. Now what do we do with all that free energy? This is where the system gets really, really clever, because it distributes the heat in two completely different ways. The whole design is based on a simple law of physics we all know. Hot air rises. The system totally leverages this, but it also heats water that can be pumped down. And just like that, you've got two separate heating circuits coming from just one fire. And this is the core of its dual-path approach. You have the smoke-hot goes-up circuit, which uses the raw heat from the exhaust to warm the walls and the upper floors. At the exact same time, a dedicated module heats water that gets pumped down for underfloor radiant heating. So you get two different kinds of heating, all from a single source.
So we know this system is efficient, but is it resilient? This next part is where the design goes from just being smart to being truly life-changing. We're going to talk about its modularity, its off-grid capability, and an absolutely incredible safety feature.
The whole system is built like a set of high-tech Lego blocks. You can swap out the heat source, you can add more exhaust modules to change the chimney height. It's completely plug and play. This isn't some one-size-fits-all product, it's a platform you can customize.
And the options are pretty extensive. According to the manuals, you can plug in a high-efficiency rocket stove for burning biomass, or an oil stove, or different utility modules for fuel and water. But notice that last one, the battery module? That right there changes everything.
This is the absolute key to its independence. Every single component, the fans, the sensors, the AI core, it all has its own dedicated battery. What does that mean? It means the G2 system can run completely off-grid. So during a power outage, your heat stays on.
And for folks who rely on battery-operated medical equipment, well, that kind of independence isn't just a convenience, it's a potential lifesaver.
That independence is amazing, for sure. But it also brings up a really critical question. With all this complex technology, what happens if something goes seriously wrong? I mean, what's the failsafe?
And the answer is just absolutely ingenious in its simplicity. If a hazard is detected, the entire high-tech system just gets out of the way and transforms back into a dumb, simple, traditional chimney. Here's exactly how it works. Whether a hazard gets flagged by the system's AI or someone just pulls a manual lever, the path to the high-tech heat-trapping system is instantly sealed off. At the exact same moment, a safety outlet opens up, creating a direct, unobstructed path for the smoke to vent outside using nothing but natural draft. It defaults to the safest, most reliable technology we've had for centuries.
So when you put all of these pieces together, the efficiency, the modularity, that incredible safety protocol, you start to see this isn't just about one house. It's really about rethinking how our homes use energy, even at a community level.
And this sketch from the manual just perfectly captures that vision. The system is powerful enough to support shared heating between two semi-detached houses. I mean, imagine that. One core system serving two homes, creating a tiny, resilient microgrid of thermal energy. It's a design that fosters not just efficiency, but also community.
This quote from the technical manual really just sums it all up, doesn't it? This was never about making a slightly better chimney. It's about redefining it from a simple vent into a central thermal processor for the entire home.
So when you put it all together, a system that's more efficient, cleaner, completely modular, and can run off-grid with an incredible fail-safe, it really makes you think, could this be the blueprint for the future of our homes and maybe even our cities? Thanks for exploring it with us.